All right, guys, today we're going to be learning how to do something called the chain rule, which is technically in every derivative problem that you do. We hadn't really been talking about it yet because um, I'll show you why. The derivative of x is 1, but basically you're pretty much always doing the chain rule. Now, when I taught this to my high school students, I would try to make it a little fun by bringing in M&Ms. So imagine that I gave all of you a package of M&Ms, okay? And I said, I want you to eat an M&M, but I want you to eat the M&M in a special way. Now the M&M has what on the outside? It has shell, right? And on the inside, what does it have? Chocolate, right? So if I ask you to eat the M&M, but I told you not to chew the M&M, and I just wanted you to let it melt, what would melt first? The thing that would melt first is the shell layer, and the chocolate wouldn't change, right? And then the chocolate would melt. And so what we're going to do is when we take the derivative of these functions, you're going to see it's a function with kind of like a shell like this, f of g of x. So the outside function is like your shell, and the inside function is like your chocolate. And so when you take the derivative, you're going to be taking the derivative of the outside first, which is like the shell. You leave the inside the same, and then you take the derivative of the outside. So if we look at this first example here, we see that I have this outer part is like my shell. I'm going to bring the 5 down, and I'm going to take the derivative just like I would the power rule. So the 5 comes down, and this becomes 4. Okay, just like we would do x to the 5th becomes 5x to the 4th. But you do not chew the chocolate. What that means is this inside part stays the same. And then on the same line, everyone say on the same line, you're going to multiply by the derivative of the inside, which in this case is 3x squared. So this answer then, I look and see what I can multiply. I can't multiply into this because it's raised to a power, but I can multiply 5 times 3 and say 15x squared, x cubed minus 2 to the 4th. Okay, let's try this one. Let me rewrite it with the shell. This time I'll use blue. So this is like to the 1/2 power. The inside is 2x plus 5. That's my chocolate. So we're going to let the outside melt first. The 1/2 comes down. This, you subtract 1, which is like subtracting 2 over 2. So this is negative 1/2. We leave the inside the same. Then on the same line, say on the same line, you multiply by the derivative of the inside, which in this case is 2. Then you look across and see what you can multiply. Remember, you can multiply a times b is the same as b times a. Like you can move around the factors you're multiplying. So 1/2 and 2 I can multiply together and say those cancel to be 1. And so my answer is 1 over 2x plus 5 to the 1/2, or 1 over the square root of 2x plus 5. All right, this one, let's rewrite it. Now, you could use the quotient rule here, but I don't recommend it because you don't have 2 functions of x. You have 1 function of x. So again, if you have a fraction or you have a root, then it's a good idea to rewrite it. So we're going to bring this whole thing up. And when we bring up that entire thing, it's going to be to still have a 3 here, but instead of a positive 3, it's going to have a negative 3. And then the inside is 4x to the 5th minus x plus 7. So we're going to take the derivative of the outside, negative 6. You subtract 1, so negative 4. You keep the inside the same. And then on the same line, you multiply by the derivative of the inside. The derivative of 4x to the 5th is 20x to the 4th minus 1. So this is our answer. Okay, this one, let's try rewriting it. You do 2x, you bring this up. Now when I bring it up, I want you to think for a second. What power is this going to be when I bring it to the numerator? It was a 3. Now what is it going to be? Hopefully you said negative 3. All right, now we're going to pull this down and take the derivative. So it's going to be derivative of the outside. Remember, you're letting that shell melt. So negative 6x, this subtract 1 becomes negative 4. The inside stays the same. You don't chew the chocolate. But on the same line, you multiply by the derivative of this, which is just 4. Then, if you have single terms, you can multiply them. So in this case, they can multiply -6 and 4, so -24, 4x minus 1 to the -4th. Sorry, that one was a little messy. Okay, next one, again, I'm going to rewrite it because I have a root and a fraction. So that's 5, 2 minus t squared to what power? Well, down here, this is to the 1/2 because the square root is the same as the 1/2 power. So, but I'm moving it up top, so that becomes to the -1/2. So your shell part is this outer function. So we're going to pull that 1/2 down. So it'd be -5/2. Subtract 1, subtracting 2 over 2 makes this -3/2. You keep the inside the same. And then you multiply by the derivative of the inside on the same line. The derivative of -t squared is -2t. You look across and see what you can multiply. I can multiply this -5/2 and this -2. The 2's will cancel and the negatives will be positive. So I have 5t. I'm going to put the t over here. 2 minus t squared to the -3/2. Let's try this one. I'm going to rewrite that root. Now this one's a little different because I have 2 functions of x. And when you have 2 functions of x, you have to do the product rule. So we're going to do the derivative of the first times the second plus the derivative of the second, which uses the chain rule. So this becomes -1/2. You keep the inside the same. And then you multiply by the derivative of the inside times the first. So let's check this out. Derivative of the first times the second plus derivative of the second. This is the chain rule here. Times the first. Hold on just a second. Sorry, guys. I had to do something with my kids. Okay, let me go back to this one. Okay, so we had the derivative of the first times the, sorry, it erased all my work, times the second, and then plus the derivative of the second, which involves the chain rule, times the first. Okay, let's try to clean this up some. So I'm going to keep this 2x and 1 minus x squared, the 1/2, like that. This 2 cancels with that 2. X times x squared is x cubed, so minus x cubed. And then 1 minus x squared to the -1/2. You can keep it like that, or you can write it as in 1 minus x squared in the bottom, the positive 1/2. Okay, this one we have the chain rule first because it's the outside function. You have to peel back the layer. Another way of thinking about the chain rule is layers of an onion that you're peeling back. So you're going to peel back this first layer, and then the inside part is where you have a fraction. And so then you're gonna have to do the quotient rule. So sometimes for students that can't see it, I put like a card with just like an inside thing cut out. So you can see like the outer function, and then you see that inner function that's left. So this outer function is, actually, I wonder if I have, no, I don't think I have a way of showing you that on this. Okay, the outer function is this to the 5th. So I'm going to pull the 5th part down, and this becomes to the 4th power. Then you have 2x plus 1 over 2x minus 1 inside. Now we're looking at just this function. And so when I go to take the derivative, remember you stay on the same line. It's all one thing you're multiplying together. It's the chain. We're going to do the chain rule here. The quotient rule. Is you're taking the derivative of a quotient. So it's going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Didn't mean to do that in a different color. Whoops, sorry. Okay, so that technically is the calculus. From here on, it would just be algebra trying to simplify this, okay, which sometimes is where students struggle, but we have 5, 2x plus 1 over 2x minus 1 to the fourth. Here I would distribute this 2, so it'd be 4x minus 2, and then minus 4x, and then minus 2. The 4x's cancel, I'm left with negative 4 there. So I have 5, 2x plus 1 over 2x minus 1, the fourth, and then on top I have negative 4 over 2x minus 1 quantity squared. You could multiply this 5 and negative 4 and say negative 20. You could also separate this to the fourth and make that to the sixth on the bottom. I understand and would accept any of those answers. Okay, so now this is just talking about all the functions you've already learned. Technically, all include the chain rule. So the derivative of sine of x was cosine of x. Technically, we were doing the chain rule already because what's the derivative of x? 1. But a lot of times it's not just an x in there. Sometimes it's a different function. So I'm going to show you an example of each of these, okay, underneath here, because I find that helpful. So say I had sine of 2x. And this would be cosine of 2x times 2. So I had cosine of x squared, and this would be negative sine of x squared times the derivative of this, which is 2x. So I had tangent of 3x. It would be secant squared of 3x times 3. If I had cotangent of x squared plus 1, it would be negative cosecant squared x squared plus 1 times the derivative of that, which is 2x. Say I had secant of x to the 1/2, which is the square root of x. It would be secant x to the 1/2, tangent x to the 1/2, and then the derivative of x to the 1/2, which is 1/2 x to the negative 1/2, all multiplied together. Say I had cosecant of x of 1 minus x, and it would be negative cosecant 1 minus x, cotangent 1 minus x times negative 1. So this negative and negative would make it a positive. Say I had e to the 2x. The answer for the derivative would be e to the 2x times 2. If I had e to the 5x, it would be e to the 5x times 5. If I had e to the x cubed, it would be, I'm going to write it in front this time just so you can see it. Not just kind of a word of warning. Usually we don't write cosine 2x times 2. Usually we put the 2 in front just because it looks nicer. So like for order, we usually put this derivative piece in front. But the chain rule basically always applies to every function that you're doing. So you just need to always think about it as you're taking derivatives. So this first one is a little tricky because you have to figure out what the outer function is. Now for trig functions, when this squared is written right here, it actually means that the outer function, like cosine, is being squared. So the shell piece is the squared here. So you bring the 2 down, which makes this become 1. You don't change the inside. You don't chew the chocolate. But then on the same line, you multiply by the derivative of the inside, which is negative sine. So our answer to this would be negative 2 cosine x sine x. Now this one is the opposite. Here the shell is the cosine part. The derivative of cosine of something is negative sine of that same something times the derivative of that something. So negative 2 sine of 2x. Now this is with them combined together, okay? So this, again, that square part means that the whole cosine thing is squared. So this would be, I bring the 2 down, I keep cosine of 2x the same, then I multiply by the derivative of this, which is negative sine of 2x times 2. Sometimes I remember when I first learned this when I was 20 years ago, when I was a senior in high school, I didn't know, how do you know like when to stop? Like you're keep multiplying, multiplying, but like if I multiply it again by the derivative of 2, that would be 0, and that doesn't make sense because it would zero everything out. You know when to stop whenever you multiply by something that's not in the original function. So here I multiplied by 2. I know I'm done because 2x is the last piece in the original function. I don't just see a 2, if that makes sense. So it's whatever if this is a part of the original function. So this is like a 3-layer M&M. Sometimes people say it's like a peanut M&M, like I have this on the inside, right? So you have that squared, cosine, and the 2x. You stop once you do the derivative of the 2x, which is that 2. This one, when it's written like this, actually means that this thing is being squared first. So I'm just going to write out what that would be. That would be cosine of 4x squared, because you square the 2 and square the x. So the outer function here is cosine, and the inner function is that. So the derivative of that would be negative sine. Keep the inside the same. Remember, you don't chew this chocolate. Multiply by the derivative. And so that's that one. Now we're doing logs and e's all at once. When I taught high school, I made this like 3 different days. So it's a lot of material at once. I acknowledge that. The rules themselves are not that hard to apply, but it is a lot at one time. The natural log of u, I always just say u prime over u. And one of my students one time came up with this phrase, which kind of stuck. Derivative of the stuff. It's not very mathematical, but it makes sense. Over the stuff. So I'm going to do that for this example right here. I see natural log on the outside. So when I see the natural log of something, I take the derivative of the stuff, the inside, put it over the stuff, which is the inside. So I literally just take the derivative of this, which is 4x, and I put it over this. Natural log is not in the answer when natural log is the outer function. Okay, so that's an example of how to apply this rule. Now this one, I have to do the quotient rule because I have a quotient. And so I have to do the derivative of the top, which then you apply this rule. The derivative of natural log of t is the derivative of t, which is 1 over t, because it's the derivative of the stuff over the stuff, times the bottom, minus the derivative of the bottom, times the top over the bottom squared. Okay, I could clean this up a little bit, but that's the idea that I want you to know. This one is tricky because it's natural log of the natural log. We have the natural log on the outside. So how do I take the derivative of natural log of something? I take the derivative of this and put it over this. Well, what's the derivative of natural log? The derivative of natural log is the derivative of x, which is 1 over x. So that's the derivative of this inside stuff. And then I put it over this. Derivative of the stuff over the stuff. If I want to make this look nicer, I can think about this. Dividing by natural log is the same as multiplying by 1 over natural log. So I could say 1 over x ln x. This one, the outer function is cosine. So the derivative is going to be negative sine. The inside stays the same. And then you multiply by the derivative of the inside, which is 5. And the derivative of cosecant is negative cosecant cotangent. This one, I'm going to take the derivative using the product rule. I know to use the product rule when you have 2 functions of x, these both have an x, and there's no plus in between. They're side by side. So I do the derivative of this one, e to the u, the derivative of e to the u is e to the u times the derivative of u. So times the derivative of this. U to the 2x times 2 times the second. Plus the derivative of the second, which would be secant squared of 2x times 2, because of the chain rule, times the first. So we have the derivative of the first times the second, plus the derivative of the second times the first. So if I wanted to clean this up a little bit, it would be 2e to the 2x tangent of 2x plus 2e to the 2x secant squared of 2x. Again, this is a lot of information at once. Just try your best and please let me know if you have questions. All right, so now this is saying if I have other bases besides natural log. So e to the u is e to the u du. E is just a number though. E is 2.7 repeating forever. It's different, or not repeating, just it goes on forever. So if I have something besides e, like what if I had 3 to the x? Well, the derivative of e to the x is just e to the x. The derivative of 3 to the x is 3 to the x times the natural log of 3. So it's just like this, because if I wrote the natural log of e, the natural log of e is 1. So it's really just one rule, but this is the derivative of that. So then this would be 3 to the 2x. So the derivative of that would be 3 to the 2x times the derivative of this, just like when I do e to the 2x, it's e to the 2x times 2. So this would be times 2, but then also that natural log of 3. So if I had 5 to the 3x, that would be 5 to the 3x times the derivative of this, 3 times the natural log of 5. If I had 7 to the 6x, I would have 7 to the 6x times the derivative of this times the natural log of the base. That's how to apply this rule, right? I know it looks weird. It's not that bad. For if it's a different log base, so if I had log base 2 of x squared plus 1, okay? If this was the natural log of x squared plus 1, and I took the derivative, it would be derivative of the inside over the inside. If I have this one, it is just like that, with one extra thing. I divide by the natural log of this base, because it's of the change of base formula, okay? So you just have to remember to add that ln of the base a on the bottom, but it's the same rule as natural log, just with that extra base. So if I did this one, first let's rewrite this. This is log 2x plus 1 to the 1/2. Now I have a whole video with logarithm rules, which you should check out, but this 1/2 can come in front, not taking the derivative. This is a rule, log b to the a is the same as a times log b. It works for any log. So this is just a logarithm property, just to make this look a little simpler, okay? So I'm not taking the derivative yet. Now, when I go to take the derivative, this 1/2 stays there because it's just a coefficient. The derivative of log of stuff is the derivative of this stuff, which would be 1, over this stuff. But since it's a different base, I have to write the natural log of whatever that base is in the bottom. Okay, let's try this one. This one is, hopefully you recognize it's the product rule, because you have 2 functions of x side by side with no plus sign in between. So we do derivative of the first times the second plus the derivative of this, this is a to the u times the derivative of u times the natural log of a. So I'm going to write 6 to the negative 2x, then I'm going to write the derivative of that, which is negative 2, and then the natural log of 6. This whole thing is the derivative of this. Then because of the product rule, you have to multiply by the first. So derivative of the first times the second one without changing it, and the derivative of the second times the first without changing it. So this would be 6 to the negative 2x plus, I'm just going to write, actually, let's not do plus. Let's do minus, because it's negative 2, right? So I have this 2 and I have x, so negative 2x ln 6 times 6 to the negative 2x. Again, you can write these in any order, because I can say 3 times 2 times 5 is the same as 5 times 3 times 2. When you're multiplying, you can write it in whatever order makes the most sense to you, okay? This, I think, is this the last example? Yeah, 2 more examples. This says find the equation. What do you do when you see the word equation? What do you say? Equation, point, slope. Equation, point, slope. So I have a point, I have a slope. The point is given to me. The slope means find the derivative. That's what calculus is all about, the derivative. Now this one, when you have that third right here, that means that that tangent function is cubed, not the 2, because the 2 is not in parentheses. But anything with this tangent of anything here, that part's being cubed. So the outer function is that cubed piece. We roll it down, we say 3 times 2, and then this becomes squared, tangent. You do not chew the chocolate, this stays the same. But then on the same line, you multiply by the derivative, which is secant squared. So the derivative is 6 tangent squared, secant squared. So then I need to apply this to pi over 4. So 6 tangent pi over 4, quantity squared, secant pi over 4 quantity squared. My unit circle is right, this is pi over 4, and the square root, it's root 2 over 2, root 2 over 2. So your tangent is 1, so that's nice. Your secant is the reciprocal of cosine. So it's 2 over root 2 squared. So this is 6, 1 squared is 1. 2 squared is 4, and square root of 2 squared is 2. So we have 6 times 2, which is 12. So your equation is y minus the y coordinate equals the slope times x minus the x coordinate. So you always just find your point, you find your slope, you evaluate your slope at your x value, and then you do y minus y1 equals slope times x minus x1. This one, determine where the function has a horizontal tangent. So when you see that phrase horizontal tangent, that means where the derivative is 0. So derivative of the top times the bottom, because this is the quotient rule, minus the derivative of the bottom, which you have to use the chain rule because you have a function inside a function, times the derivative of the inside, times the top all over the bottom squared. Derivative of the top times the bottom minus the derivative of the bottom is chain rule times the top over the bottom squared. Okay, when I'm setting a fraction equal to 0, you don't care about this bottom. So it just would 0 out. You just care about when the top equals 0. So let's try to clean this up. 4x cubed, 3x minus 8 squared minus, let's see, 6 x to the 4th, 3x minus 8. Okay, so what we're going to do is look for GCFs to factor. So I see 4 has a 2 in it, and this has a 2 in it. X cubed, x to the 4, so we can take out x cubed. And we can take out, whoops, I did not mean to write a 6. We can take out one quantity of 3x minus 8 because we have 1 here, or we have 2 here and 1 there. So I factored out 4, I factored out 2, so I'm left with 2. I factored out x cubed, so I just have nothing there, and I factored out one of those quantities, so I have 3x minus 8. Minus, I took 2 from that, 6 divided by 2 is 3. Divide that by x cubed, so I'm left with 1x, and I took that, I divided it out. So that means I'm gonna write over here because I'm running out of room. So I have 2x cubed, I have 3x minus 8. And then if I simplify this, that would be 6x minus 16 minus 3x. So 2x cubed, 3x minus 8, and then I have 3x minus 16. If I set each thing equal to 0, that's figuring out where it has a horizontal tangent line is where each of these equals 0. So that would give me x equals 0. This would give me x equals 8/3. And this would give me x equals 16/3. So you have 3 places. Oh, actually, I do need to pay attention to something. And just ignore this bottom, which usually works okay, but you have to be careful because you don't want it to be undefined. You want it to be 0 over a number. So you do need to make sure that the function exists there. This function doesn't exist where this bottom equals 0. So where x equals 8/3, the function is undefined. You have a vertical asymptote. So I need to throw out this one because it's undefined there. So really you just have these 2 places here because you need to check that only the top equals 0 and the bottom doesn't. Sorry, I usually do okay. Like a number over any other, 0 over any number is okay. But since this function is undefined at 8/3, you can't include that. You're not going to have a horizontal tangent line there because you have an asymptote there. The function doesn't even exist there because the bottom of this original function equals 0 there. So just be careful with that when you have a fraction. Okay, so that was a lot, guys. Big idea, chain rule. Here, let me actually stop this one and start a whiteboard. If I had to boil this down to what you're trying to remember, oh, sorry, one of my kids is drawing on this. Okay, so we have the chain rule. F of g of x. When you take the derivative of the outside don't change the inside, and then you multiply by the derivative of the inside. And we covered all of trig derivatives. We covered all e to the u is e to the u times the derivative of u. A to the u is just like that. The times the natural log of a. Natural log of u goes u prime over u. Log with any other base is also just like that, but has element of a in the bottom. So those are the things we covered. Okay, so to give you one last example, if I had something like x cubed plus 1 to the 5th, the derivative of that is 5, x cubed plus 1 to the 4th times the derivative of this, which is 3x squared. If I have e to the cosine x, the derivative would be e to the cosine x times the derivative of that, which is negative sine. If you had 7 to the 2x plus 1, the derivative would be 7 to the 2x plus 1 times 2, that's the derivative of this, times the natural log of 7. If you have log of anything, let's do log of sine for fun. The derivative of is going to be u prime, so the derivative of this over this itself. If I had a log with a different base, it's the derivative of this stuff, so 2x over the stuff with the natural log of whatever the base is in the bottom. That's kind of a high level quick recap, but make sure you memorize all of those trig derivatives and that you understand when to do the chain rule, the product rule, the quotient rule, and just always check for the chain rule. And as always, please let me know if you have questions, and good luck on your assignment.